Hello everyone. We are going to begin a new topic, that is sound fields and measurement of noise. In this topic, we shall see what are the various terminology which we can use in the noise measurement, or we can say what are the various terminology related to noise are needed in noise measurements. What are the components of the sound level meter? What are the various sound fields which are needed during the sound or noise measurement? So let us begin the terminology which are needed in the measurement of noise using integrating sound level meter. So this is integrating sound level meter. So the first terminology is the weighing networks. The weighing networks in sound level meter, you can say in the short form, this is the microphone. This part is the processing unit, and this the bottom part is the display unit where we can see the results. So weighing networks in a sound level meters attempt to alter this is very important terminology, measured signal in a similar fashions as human hearing mechanisms. As per the human hearing mechanisms, the networks can alter the measured signal. Networks are the electronic circuits or filters built into the sound level meter that implement the frequency weighing. What are the frequency weighing? A weighing, B, C. So in this topic, like what is the A weighing, B weighing, or C weighing, or that also we shall talk in the next slide. So we shall see under the weighing networks. The first one is the frequency weighing. Frequency weighing means it mimics human ear sensitivity to frequency. It refers to the adjustment, filtering applied to the sound signal to mimic how the human ear perceives sound at different frequencies. The human ear is not equally sensitive to all the frequencies. Remember, please, it is most sensitive to mid frequency, that is in between 1 kilohertz to 5 kilohertz, and less sensitive and very low, and less sensitive to very low and very high frequencies. A human hearing mechanism is like that. So noise measurements, we apply filters, that is nothing but weighings, to make the instrument response similar to our hearing mechanisms. This is very important, we have to understand. So first one is the frequency weighing. Next, we can see under the frequency weighing, what are the A, B, and C frequency weighing that is used in the integrating sound level meter or sound level meter. We can see the A weighing means we have already discussed the definition of decibel, which is the unit of a sound, right? Unit of the noise. So whenever we are going to measure the noise, we have to write the values dBA. For example, suppose we are going to get the 90 decibel. That means we are going to write in this case the 90 dBA. So A weighing means the A weighing filter closely follows the frequency response of the human ear at moderate sound levels. Human ears are less sensitive to very low and very high frequencies, and most sensitive to mid frequencies, which we have seen in the previous slide, one in between 1 to 5 kilohertz. Therefore, A weighing gives results to correlate well. This very important things. It correlates well with how people actually perceive loudness and avoidance. The next weighing is the B weighing. We can represent the decibel unit dBp. It is obsolete. It is not in use in present situation or in present day. It has become obsolete. So B weighing correspond to the ear response at medium to high sound levels. We can see here it does not significantly differ from A weighing, right? And provides no practical advantage. So it is not used nowadays. The next weighing, we can see C weighing. C frequency weighing. It is denoted by dBc. The measurement, suppose 90 dB C, we can write is used only for the special purposes. C weighing represents hearing at very high sound levels and includes more low frequency content. It is mainly used for measuring peak or impulse. This we can remember. The C weighing, C frequency weighing, we can use only at the time of peak or impulsive noise measurements. For example, explosion or machinery impact, right? Not for general noise evaluation. We cannot use the C wave. We can use the A wave. So mostly we are going to use the A frequency wave while denoting the values of noise. Now the next thing we can see the time wave. The first terminology was the first frequency wave. The next is the time wave. So that means it controls how meter responds to sound fluctuation over a time. It takes care of the time, while sound measurement or noise measurement. Time weighing refers to how quickly a sound level meter responds to changes in sound pressure level over a time. Whenever we are going to use the integrating sound level meter, how at the time of measurement, how this the level, sound level is going to vary within a periods, right? It ensures stable readings even for fluctuating sounds. So whilst setting up this integrating sound level, we have to also set the time weight. What are the various time weight? We can see the fast, slow, and impulse symbol. We are going to use F, S for slow, I for impulse. So time constant you can see here 125 millisecond, in this case 1 second, and 35 millisecond in this case. So up to these periods, it can measure the sound in a proper way. So what does it mean? We can see the meter responds quickly, useful for measuring rapidly fluctuating sound. Example, a speech or conversation, office or classroom talk, rapidly varying sound levels from fans or engines, etc. The display needle or reading moves rapidly in this case. But whenever we are going to keep the sound level meter in fast time weighing mode, right? It can measure the sound values or noise values for these different situations, speech or office or classrooms noise, right? The next is the slow. In this case, the meter responds more slowly. The reading is more stable and easier to observe. For example, general environmental noise survey, continuous noise, industrial noise measurement. Whenever we are going to use the noise level meter in the industry, in the case of industrial noise measurement or community noise measurement, in that case we can set the time weight as S in the instrument itself. The third one is the impulse. That means very quick response to sudden sound peaks. Suppose hammering is there, hammer strike or hammering is going on, or gunshot. In that case, we have to put the sound level meter in impulse mode. The short 35 millisecond rise time lets the meter detect and capture the sharp impulses before they disappear. So within 35 seconds, it will capture the sound level. So duration is also important, right? The time weighing is very, very important while going for the noise measurement. So it allows the instrument to detect short duration noise peaks accurately. So this based on our experience, depending upon the situations, we can use the noise level meter or integrating sound level meter in different time weighing mode. Next, we can see the terminology root mean square sound level, right? Root mean square level. What does it mean? The RMS level represents the average effective sound pressure over a given time periods. It is what we usually perceive as loudness or continuous sound level. So RMS value is typically frequently weighed using A or C. B is obsolete. So we are going to use only A or C, frequency weighing. So we can see that whenever we are going to measure this sound, we can get the values, values, RMS level, right? What does it mean? It is written here. The next terminology, the peak sound level. The peak level represents the maximum instantaneous pressure that occurs during the measurement period. The highest sound spike. It captures very short duration impulse or impact noises, as I told you in the previous slide, gunshot or hammering. In that case, we can get the reading, we can get the results that is called a peak sound level. So, or impact noises that may not affect the average RMS values much, but are important for hearing safety. So, sound level meters can record RMS, root mean square values, average sound values, and peak levels at the same time instead of measuring them separately. So this is the characteristic of integrating sound level meter. We can measure these RMS values and peak values simultaneously. It is not required to measure separately, or at the same time we can get both the values. Next terminology we can see equivalent continuous sound level. For constant sound levels, there is no problem. It is easy to measure the sound level using the sound level meter. But if the sound level varies, the level must be sampled repeatedly. Suppose while measuring the sound level using sound level meter for any source, and in that case we can see the level that means the noise level is going to vary repeatedly. So what in that case what we can do? It is required to measure this sound repeatedly for different sound level, right? Over well-defined sampling periods. So based on these samples, what we have to do, it is then possible to calculate a single values, because for different level, for different noise levels, we have to take the equivalent continuous sound level. That means we have to find out the single values as the equivalent continuous sound level, which is denoted by LEQ, equivalent noise level LEQ, which has the same energy content and consequently the same hearing damage potential as the varying sound level or repeatedly sound level have. For A weighted, A is the frequency weighing, LEQ, in that case we write the symbol LAEQ. That means the equivalent sound level or equivalent continuous sound level having frequency weighing A. So if the sound level varies randomly, it is not easy to use manual calculation to evaluate the values of LEQ. So in that case, we normally use nowadays the integrating sound level meters are available in the market. We can use that instrument to calculate the values of LAQ. It automatically calculate. This instrument automatically calculate the equivalent continuous sound level values. This is required for our study purpose. This data is required. This result is required. So next, the topic we can see components of integrating sound level. What are the various components? We can see the first one is the microphone. The microphone, it receives the sounds and converts acoustic pressure sound into an electric signal for the further processing. It is protected by using a wind screen which is kept here. Next, it comes to after microphone, it comes to the preamplifier. A preamplifier strengthens the weak electric signal from the microphone before it is passed through the main processing circuits. So the third one is the signal processing and weighing circuits. So this is the heart of the instruments. This part is the heart of the instruments which applies the required frequency weighing, whether it will be A weighing or C frequency weighing, and time weighing, which may be fast, slow, or impulse. So this frequency weighing and the time weighing, we can set up in the instrument itself. And finally, we can see this is the display which shows the results. The bottom part is the display. Now we can see what are the various types of sound fields. and noise measurement techniques, how we can measure the noise. So the first things come in our mind whenever we are going for the noise measurement or sound measurement using a integrating sound level meter for any source. In that case, it comes in our mind that how we should keep the instrument nearby the source. That first point comes in our mind. So for that, we have to know about the different sound fields, near fields, reverberant fields, free fields. What does it mean? So near field, we can see what it says that if measurements are made too close to the machine, that means too close to the source of sound generation, the sound pressure level may vary significantly with a small change in sound level meter positions. This will occur at a distance less than the wavelength of the lowest frequency emitted from the machine, or at less than the twice the greatest dimension of the machine, whichever distance is greater. This situation will occur. So this area is termed as near field of the machine. Measurements in this region should be avoided if possible because more fluctuation will be there. So next field is the reverberant field. So other errors may arise if you measure the sound level too far away from the machine. In that case, what is going to happen? The reflection from the walls and other objects may be strong compared to, this is actually word compared to direct sound from the machine, and correct measurements will not be possible. This region is termed as reverberant field. We can see the next field is the free field. Between the near field and reverberant field is called as free field, which can be found by noting. How we can find out the free field in between these two fields? By noting that the sound level drops 6 decibel for each doubling in a distance from the source. Whenever you are going to double the distance from the source, and if you find the fluctuation of the noise level 6 decibel, that means that zone is the free field zone, and sound pressure level measurements should be made in this region. So now the third thing is the microphone and its orientation. How we have to keep the instrument in our hand, how we have to orient the microphone. That is also one of the main important criteria during the noise measurements. You can see the type of microphone and its orientation in the sound field also influence the accuracy of the measurements, its orientation. Selection of most appropriate microphone may also be influenced by applicable national or international standards. So it depends upon the standards also, right? For example, International Electrotechnical Commission (IEC) standard is also there. Specified sound level meters with free field response. That means IEC says that whenever we are going to measure the sound for any source, in that case we should keep the microphone, or we should keep the instrument in the free fields zone. Whilst the American national standards, ANSI, American National Standard Institutes, calls for random incidence response to be used. That means random incidence microphone means what? That type of microphone is used for measuring this sound. In that case, sound comes from many directions. So what it says that the random incidence microphone is for measuring in sound fields where the sound comes from many directions. But if a random incidence microphone is used in a free field environment, the most accurate measurement is obtained where it is oriented at an angle of between 70 and 80 degree to the sound source. That should be taken care of. So under the microphone and its orientation, to minimize the reflection of sound from your body, that is also one of the criteria. Whenever you are keeping the instrument nearby your bodies, the sound level will vary. Hence it says that it is usually sufficient to hold the sound level meter at a arm length. It may also be mounted on a tripod. So both options are there. You can keep this sound level meter in your hand at arm length, or you can mount on the tripod also, fitted with its extension rod. You can check whether your presence is influencing the meter reading by letting the sound level meter remain fixed while you step from side to side. So that also you can watch yourself. The operator should be at least 0.5 meter away from the nearest station. So outdoor measurements are made 1.2 to 1.5 meter above the ground and at least 3.5 meter from the reflecting surfaces such as buildings. So indoor sound measurements should be made at least 1.2 to 1.5 meter above the floor, at least 1 meter from the walls and 1.5 meter from the windows. The last point we can see, it is very important. Measurements are normally made with windows closed unless they are regularly left open. If this is the case, if it is kept left open, in this case what we can do, measurements are made with window closed and windows open. So both the things we have to follow. Next we can see the display unit. It is the last stage of sound level meter. A display unit means the readout unit which displays the sound level in decibel. And using this integrating sound level meter, we can measure the sound. We can measure the 4 parameters simultaneously. So varieties of sound level meters are there in the market. So depending upon our requirements, we can purchase accordingly. So first parameters we can see the LAF, that means instantaneous sound pressure level, frequency weighing A and time weighing fast. LAF max, that means maximum sound pressure level, frequency weighing A and time weighing fast. It is also mentioned in this abbreviated words. The next one is the LAQ, equivalent continuous sound pressure level, having frequency weighing A. The last one, LC peak, means maximum peak sound pressure level, having frequency weighing C. So we can measure these parameters, noise parameters, simultaneously using the integrating sound level meter. It also depends upon our requirement. So in this lecture, we studied about what are the various terminology needed for noise measurements. What are the components of the integrating sound level meter or sound level meter? What are the uses of sound fields in noise measurements? And what are the various techniques which are required for the measurement of noise? Thank you.